Welcome to Physics Dream Team Classroom, College Matrikulasi Pahang Kementerian Pendidikan Malaysia.
Assalamualaikum and hi to everyone. For Physics Semester 1, what is the first chapter that we're going to learn? We're going to learn Chapter 1, Physical Quantities and Measurement. Physical quantities and measurement can be divided into three subtopics. The first one is dimensional analysis. The second one is scalar and vector. And the third one will be significant figures and uncertainty analysis that you will learn during the lab session. For the first learning outcome, 1.1, Dimensions of Physical Quantities, at the end of this chapter, students should be able to define dimension. 1.1, Dimension. What does it mean by dimension? Dimension is defined as a tactic or method which the physical quantity can be expressed in terms of combination of basic quantities. It can be written as open bracket physical quantity or its symbol close bracket. Table 1.5 shows the dimensions of basic quantity. You must remember the dimensions of basic quantity as shown in the table. Scalar and vector quantities illustrate unit vector I head, j head, and k head in Cartesian coordinate. State the physical meaning of dot or scalar product, where vector A dot vector B is equal to AB cos theta. State the physical meaning of cross product or vector product. Vector A cross vector B is equal to AB sin theta, where the directions of cross product can be determined by using corkscrew method or right hand rule method. Do you know that the physical quantities have two types of quantities, either scalar quantity or vector quantity? 1.2.1 Scalars and Vector. What does it mean by scalar quantity? Scalar quantity is defined as a quantity with a magnitude only. The example will be mass, time, temperature, pressure, electric current, work, energy, power, and etc. On the other hand, for vector quantity, we can define as a quantity with both magnitude and direction. For example, displacement, velocity, force, momentum, electric field, magnetic field, and etc. All the quantity got magnitude and also direction. 2.2 Illustrate unit vector I head, j head, and k head in Cartesian coordinate. 1.2.2.1 Unit vector. A unit vector can be said that they have no unit. While unit vector for three-dimension axis, which is for x-axis, can be represented by using I head, for the y-axis can be represented by using j head, and for the z-axis can be represented by using k head. The magnitude for all the three vectors, the magnitude of I head is equal to the magnitude of j head equal to the magnitude of k head, which is equal to 1. Point 2.2.2 Unit vector I head, j head, and k head in Cartesian coordinate. Given the figure for the three axes, x-axis, y-axis, and also z-axis. For a unit vector I head, We can draw the vector at the directions of x-axis as shown in figure. For the unit vector of j, we can draw at the y-axis as shown given, and for the k head, we can draw at the x-axis as shown given. Vector can be written in terms of unit vectors as, for example, if you were given a vector r, therefore vector r is equal to rxi head plus ry component j head plus rz component k head. The magnitude of the vector can be found by using the below equation, where r is equal to square root of rx square plus ry component square plus rz component square. There are two types of multiplications of vector. The first one will be scalar or dot product. A dot product conceptually is the projection that one vector has over another. This is why it is a scalar. It only tells the length of the projection. Given in the figure two vectors, vector A and also vector B with an angle theta. When we do A dot B, it will be projections of vector B to vector A. What does it mean by that? It is going to be component of B parallel to A, as shown in figure, where the red line representing the component of B that parallel to A, or the projections of B with parallel to A. Therefore, A dot B is going to be equal to magnitude of A times with the component of B parallel to A, or mathematical equation A dot B is equal to AB cos theta, and it will produce a scalar quantity. Another way of thinking is that it tells one how parallel the two vectors are to one another. Given in the figure vector A dot vector B, where the red line shows the vector B that is parallel to vector A, component B parallel to A. What we can conclude, the angle theta range from 0 degree to 180 degree. If the theta is greater than 0 degree but less than 90 degree, therefore the scalar product is going to be positive. If the theta is between 90 degree to 180 degree, the scalar product will be negative. When the theta is equal to 90 degree, the scalar product will become 0. If vector B being dot with vector A, given that in the figure vector A and also vector B with angle theta, when we do B dot A, what will happen? So if you look here, vector A will be projected parallel to vector B as shown using the red vector. The red vector representing the projections of vector A to vector B, or component of A being parallel to component B. B dot A will be equal to the magnitude of B times with the component of A parallel to B, or mathematically we can write as B dot A is equal to BA cos theta. The scalar product obeys the commutative law of multiplication. Therefore, A dot B will be equal to B dot A. Therefore, in general, vector A dot vector B is equal to AB cos theta. Theta is the angle between two vectors. The example of scalar product is work done by a constant force where the expression is given by work is equal to vector F dot vector S is equal to Fs cos theta. 1.2.4 Vector or cross product. Cross product of two vectors will produce the new vector and its direction is always perpendicular to the two cross vectors. Given that a vector A be crossed with a vector B at angle theta, vector A cross vector B will produce vector C that is perpendicular to vector A and B. So how are we going to determine the directions of vector C, the new product? So we can determine the directions of the product C by using the right-hand rule to determine the directions of the cross product produced. Given that A cross B will produce C, that is the directions of vector C is downward. On the other hand, if you do vector B cross vector A, you will also produce vector C, but the direction will be opposite, which is, in these cases, the directions of C is upward. Therefore, A cross B is not the same as B cross A, but A cross B is equal to negative B cross A. A cross B is equal to B cross A is equal to AB sine theta n is equal to BA sine theta n in order to get the magnitude of the cross product produced. Example of vector product or cross product is a torque or moment of force on a material, where the expression is given by, in the form of vector product, torque is equal to vector R cross vector F, and the magnitude form can be written as torque of the vector is equal to Rf sine theta. Therefore, in general, the vector product is defined as A cross B is equal to C, and its magnitude is given by A cross B is equal to C equal to AB sine theta n, where theta is the angle between two vectors and n is a unit vector perpendicular to the plane containing A and B. The direction is being determined by using the right-hand rule. If the theta is ranged from 0 degree to 180 degree, so the vector product produced is always positive value. Vector product, it is a vector quantity. So that is all for our learning today. Let's have a look on the objective question. For objective questions, the question is, what is the definitions of dimension? Is it the answer is A? Or is it the answer is B, C, or D? Have a look. Have a think. So what is actually the correct answer? The correct answer for the first question will be, the answer is A. So with that, that's all for our learning, and try to do the rest of the question by your own. Have a rest, take care, and thank you.